Let A be the area of a circle with radius r. If dr dt equals 3, find dA dt when r equals 1. Round to 3 decimal places. Okay, so we have a circle, and this circle has a radius of r. So nice little circle here. Centers are generally useful, and radius is r. If dr dt equals 3, so that's a piece of information that's going to be useful, find dA dt, so that's missing, I'll just put a question mark for it, and we have r equals 1. Okay, so not a lot of information given here, but there is actually enough to figure this out. So A is telling us about area, and of course r is telling us about the radius. And you should be familiar with the formula that relates area and radius together. So the area of a circle is pi r squared. Now, they're not saying to take these numbers and plug into this formula. That's not going to get you the correct answer. You are relating derivatives here. So we have to take this formula and change it in such a way so that we are finding the derivative, relating the derivative. So this is a related rates formula that we're looking for. Now, to do that, notice that we are differentiating with respect to the variable t, which is time. Time is not a variable in this equation, but we are assuming this is somehow a circle that can change size with respect to time. So the radius can grow, and what that does is it changes how the area grows. So we're trying to get a formula that relates how these two variables change with respect to time. In order to do that, we have to differentiate this formula implicitly. So differentiating this implicitly would look like the derivative of a variable a with respect to time. So a itself would be a linear variable. Its derivative is 1. But when we differentiate a variable with respect to some other variable through implicit differentiation, we then multiply by the derivative of the inside part, which is dA dt. And you might be thinking, oh, that just looks like I just replace it with dA dt. And you'd be right. That's exactly what you're doing. Now, going to the other side, we have the constant pi. Nothing happens there. It's just a number. But then we have r squared. R squared is an outer function for which we differentiate normally, which would be 2r. But then we multiply by the derivative of the inside function, which is again going to be dr dt. So the dr dt is the rate of change of the radius with respect to time. Now, you have to have that because this is part of the equation. A piece of information that was given was dr dt, so where would we put it otherwise if we didn't have this formula? So let's simplify this. We'll say dA dt equals 2 pi r dr dt. And to find the rate of change of the area with respect to time at a particular point in time, that's going to be dA dt when r is equal to 1 is going to be 2 pi times r times dr dt, which in this case, oh, I'm sorry, r is 1. 2 times 1 times 3 would be 6, so 6 pi, or you could approximate that if you so desired. Just use your calculator. And 6 pi is 18 point, how many decimals? 3, so 850. Okay. Now, another thing that I want to mention is units of measure are important, and units of measure have to match up on both sides of an equation before an equation even makes sense. So if you think about the rate of change of area with respect to time, we weren't told what units of measure were really being used in this particular problem, but let's say that the radius is measured in, um, let's say, feet, okay, and time is measured in seconds. So dr dt is measured in the rate of change, the measure, which is feet per second. dA dt is square feet per second. So if we look at the units of measure in this formula here, dA dt is squared feet per second because it's area changing per unit time. 2 pi is just a constant. It doesn't have a unit of measure. R is feet. Now, most students who have a problem in this question don't know that they need to have this value here, and they just differentiate um, pi r squared as they would normally, but that's something different. That's actually dA dr, which is different from dA dt. And the reason that's important is because the units of measure don't work out without that additional dr dt, because square feet per second is not the same thing as feet. But if I multiply that by dr dt, which is feet per second, feet times feet is the square feet per second. So then now the units of measure match up.